In this video, we'll explore a complex cybersecurity concept, the Return Address Overwrite, an attack used to hijack the execution flow of a program, but we'll do it in an astonishingly simple way using only an ATmega328 microcontroller, assembly code, and a free online tool called AVR-compiler.js. When your program calls a function, it writes a ticket saying, "Come back here after," and places it on top of the pile. This ticket is the return address. When the function finishes, it reads the last ticket and jumps back. It continues as if nothing happened. This concept applies universally, from simple 8-bit microcontrollers to complex modern operating systems. First, we execute an innocent program where the LED turns on and stays on as expected. If we disassemble this code, we clearly see that the infinite loop begins at address 0x62. This detail is crucial because in the second part, the attack, we will forge a fake return address that jumps exactly to this point. Then we add a hacked section that overwrites the stack. What happens? The program starts executing from our hacked code instead of the original function. It turns the LED off and writes a fake return address onto the stack, pointing to the normal loop. When the ret instruction executes, it jumps to this loop address and continues as if nothing happened. So the LED is off, but the program flows normally. Why is this important? Because this is a real working example, not a simulation. The tool we use compiles, uploads, and disassembles actual code. Using ATmega328 and assembly lets us see instructions, addresses, stack operations, registers, and control flow, all visibly and clearly. In a world where exploits hit modern cloud systems and complex devices, understanding these basics with simple tools prepares you to grasp even the most advanced attacks. To conclude, we have demonstrated a very advanced exploit technique, the return address overwrite, on one of the simplest microcontrollers available. With just a few instructions and an LED, we simulated a real attack. In future videos, we will explore how the stack is also used to pass parameters to functions, which opens even more interesting possibilities, but that is a story for another time. For anyone curious to try this hands-on, the online tool http://costicncg.github.io/avr-compiler.js/avr-compiler-js is free and lets you assemble, disassemble, and test AVR assembly code live. That's it. We've seen how a powerful exploit works using just basic tools and the ATmega328. If you found this useful or interesting, leave a like or a comment. It means a lot. See you in the next video where we'll go even deeper into how the stack works in function calls. Thanks for watching.